Welcome to day 22 of our low-level design journey. Today marks a significant milestone as we will be working on our first major pattern integration project. Our goal is to combine multiple design patterns we have learned so far into a cohesive real-world system, a notification system. We will focus on three critical aspects of software design: extensibility so that the system can grow easily, maintainability so that it remains easy to understand and change, and scalability to ensure that it can handle growing loads smoothly. Let's dive deep and make all our learnings so far come to life. Let's start by truly understanding the problem we are going to solve. Imagine we are building a notification system for a product like Amazon or Uber. Notifications must be sent via multiple channels: email, SMS, push notifications, even WhatsApp. Different types of notifications need to be handled: alerts, reminders, promotions. Crucially, the system should allow easy addition of future channels like Slack or Microsoft Teams without needing to rework the core design. Moreover, the system must be reliable. If a notification fails, it should automatically retry. And since we could be sending notifications to millions of users, the system should efficiently handle bulk operations. Finally, business logic like payment or booking should remain decoupled from notification mechanisms. This is the real world problem we are solving. Design patterns are tools in our toolkit, and depending on the requirements, we carefully pick the right ones. For dynamic creation of different notification types, we will use the factory pattern. To ensure reliable delivery, especially if the first attempt fails, we will introduce a command pattern combined with a retry mechanism. To decouple notification logic from business logic, we will use the observer pattern so that business components can simply raise an event and not worry about how notifications are sent. To efficiently create multiple similar notifications, say for a promotional blast, we will use the prototype pattern. When we need to dynamically add behaviors like encrypting a message before sending, the decorator pattern fits perfectly. And to hide the complexity behind a simple interface for clients, the facade pattern will serve us well. Always remember, good design is about choosing the right patterns to solve the right problems. Now let's zoom out and look at the system's architecture. We are building an event-driven system, meaning notifications are triggered by events like payment success or new friend request. These events trigger the event manager, which then notifies the relevant observers. Notification commands are queued separately from the main application flow, making the system asynchronous and resilient. The factory dynamically creates the right type of notification based on configuration. Finally, the notification manager, acting as facade, gives client code a clean, easy to use try entry point without worrying about what happens internally. This separation of concerns ensures our system remains scalable, maintainable, and testable. Let's now break down the key components we will be building. First, we define a notification interface that all specific notification types, email notification, SMS notification, push notification will implement. The notification factory will handle the logic of deciding which notification object to create at runtime. The notification service will handle sending logic and manage retries. The notification manager, serving as a facade, will provide a simple API for clients to request notifications. We will also implement a notification command class to encapsulate sending logic along with retry strategies. And finally, the user event manager will handle business events and trigger observers that generate notifications. All of these components will work together like a well-oiled machine. Here's how everything fits together in runtime. First, a business event occurs, such as a successful payment or order placement. The event manager detects this event and notifies all registered observers. Each observer responsible for a specific notification channel or type creates a notification command and places it into a command queue. A separate notification processor pulls commands from the queue and, using the factory, creates and sends the appropriate notifications. This architecture keeps our business services fast and responsive as notification sending happens asynchronously. Now it's time for you to apply everything we have discussed. Start by implementing the notification interface along with its concrete classes like email notification and SMS notification. Next, build a factory that can dynamically create notification instances based on input type. Then implement an event manager that allows observers to register and receive events. Introduce command classes to encapsulate send logic and retries. Finally, bring all this together under a notification manager that acts as a facade. Remember, focus on writing small, single responsibility classes that are easy to extend later. As you design, keep these critical best practices in mind. Always adhere to open closed principle. Your system should be open for extension but closed for modification. Respect the single responsibility principle. Each class should have one clear focused job. Design for extensibility by anticipating future channels like WhatsApp, Slack, or even voice calls. And finally, focus on testability. Make sure retry logic, factories, and services can be unit tested independently. These practices will make your system future proof and significantly reduce bugs and maintenance costs. Here's a quick mini assignment to test your design. Add a new channel, WhatsApp notifications into your system. Observe, did you need to change existing classes or could you simply add new ones? How easy was it to update your factory? Were your observers able to handle the new type cleanly? This exercise will reveal if your design is truly flexible and extensible or if it needs further refinement. To wrap up, remember this key lesson. In real-world systems, multiple patterns are often used together to meet diverse requirements. Designing for extensibility and decoupling from day one saves massive headaches down the road. In today's project, we combined factory, observer, command, and facade patterns to build a notification system that is scalable, maintainable, and resilient. Keep practicing pattern integration. It's the difference between being a good designer and a great one. Finally, let's look at the UML diagram summarizing today's work. You will see the notification interface and its concrete implementations like email and SMS. You will also notice the notification factory responsible for dynamically creating these objects. Commands are used to queue sending actions reliably. The observer system cleanly separates business events from the notification system itself. Study this diagram carefully. It's a blueprint for building robust, real-world, event-driven system. Thank you for your attention.